determine whether each point lies on the line. So how are we gonna find these points is the line on the line or the plane? We have to plug in the numbers. Plug in the numbers for each point. So for example, for the first one, they're telling you x equal -1 plus t -1 plus t and y equal 4t and z equal 5 plus t.
Sir, isn't x equal to -5 plus t?
-5 plus t. So let's check that. Here's the 3 point and 5 plus t, yes. The first point is 0, 20, and 10. That means this is x1, y1, or z1. How are we gonna plug in these? How are we gonna check that? Oh, x, y, z. You don't have to say 1 because we have the parametric equations. So let's plug in the first one, plug in the y here, and plug in the z here. And solve it for t, you have to get exactly the same scalar. That means plug in 0 here. That means 0 is going to be -5 plus t. In this case, t is going to be equal 5. Let's check the second one. Plug in 20 here. That means 20 is going to be 4t. Divide by both sides by 4, t is going to be equal 5. The third one, we're going to plug in z equal 10. That means 10 equal 5 plus t. So in this case, t is going to be equal 5. We're going to move the 5 to the left side. You see, we got exactly the same t. That means this point belongs to these 3 parametric equations or the line. It doesn't matter. So we're just going to choose yes. There's another one. It says 5, 6, 11. The second point. This is A. This is B. You're going to use exactly the same line. The point is 5, 6, 11. 5, 6, and 11. X, Y, Z. Again with the X. So 5 is going to be -5 plus t. In this case, t is going to be equal 10. Because you're going to move to the other side. -5, move to the other side is going to be 10. Let's check the second point. 6, plug in 6 in the y. So 6 is going to be equal 4t. That means t in this case is going to be 3/2. 6/4, simplify to 3/2. Plug in the z here. Z is going to be 11 equal 5 plus t. That means t is going to be equal 6. 3 different c, that means this point not belong to the line. C, the last one, the point -7, -8, and 3. -7, -8, and 3. Let's check if this one belongs to the line or not. Again, -7 in the x. So -7 is going to be equal -5 plus t. That means t is going to be equal -2. T is a scalar, is not a time. Is a scalar. That means negative scalar is going to be goes to the different direction. Plug in -8 in the y. So -8 is going to be 4t. That means t is going to be equal -2. Plug in 3 in the third one. So 3 is going to be equal 5 plus t. T is going to be equal -2. So this point is belong to the line. That's it for this example. So this one is not, this one is yes. If it's another point, that means going to be numbers here. So this is the first parametric equation, the second one, the third one. Now we need to find the symmetric equations. This one is going to be x minus x1 over a, and y minus y1 over b, and c minus z1 over c. So it's going to be x minus 0, 0, 0. So x minus 0 over a, which is 8, and it's going to be x over 8. And here is going to be y minus 0 over b, which is 1. So it's going to be just y. That means this one equal this one, and equal z minus 0 over c, which is 5. So it's going to be z over 5. So this is the symmetric equation. That's it for this. For question 2. So we're going to write down the parametric equation, enter your answer and separate comma. So here's going to be 8t, comma, and just t. I think we have to write down like this. I'm not sure. That means this is the y. And the third one is going to be, oh, no, we have to write down x and y and z. So be careful here. X is going to be equal 8t, comma, y is going to be equal t, and comma, z is going to be 5t. Z equal 5t. You have to write down the whole equation. Let's separate this with the comma. The symmetric one, you see 8, x over 8, y, and z over 5. So this one is going to be the second one. That's it for this question. The same thing exactly, you're going to go do it with the question 3. But now we have point, and here is the parallel, here is the line. Now, here's the thing. With the first one, they give you the vector v, 8, 1, 5. With this one, they give you parallel to this line, which is a parametric equations. You see, x equal. That means the vector from this one, the vector is going to be, this is the A, this is the B, and the C is going to be 1. So that's the difference. It's a little bit different than the first question. So for question 3, I'm not going to solve it, just showing you. The point is -2, 6, and 3. On the left, they give you symmetric equations for the line, which is x over minus 1 over 2 equal y plus 1 over -3 equals z minus 5. That means this is over 1. This is A, B, C. So the vector is going to be 2, -3, and 1. So I have point, I have vector. I can use these two information to find the parametric equations, which is, let's do it, x equal x1 plus 80. That means x is going to be x1, which is -2, plus 2t. There's the first one. Y equal y1 plus bt. That means y is going to be y1. Y1 is 6 plus b is -3, so it's going to be minus 3t, and z equal z1 plus ct. That means z is going to be z1, which is a 3, plus c is 1, so plus t. So here is the 3 parametric equations. So the first one is going to be -2. That means x equal -2 plus 2t, comma, y is going to be equal 6 minus 3t, comma, z is going to be 3 plus t. Z equal 3 plus t. Here is the 3 parametric equations. What about the symmetric one? How are we going to find the symmetric one? It's going to be x minus x1 over a, y minus y1 over b, that's comma, equal z minus z1 over c. So x minus x1, which is negative 2, so it's going to be plus 2 over a. Here is the vector, so a is 2. Equal y minus y1 is 6 over b. Here is b, which is negative 3. Equal c minus d1, which is 3 over c, which is 1. So which one is the right one? You have to choose y minus 6 and plus 2 and z minus 3 over 1. So this is the right one. That's it for this. We're going to create vector between this point and this one. So the first component minus 7, 2 over 5 minus 5, and 1 minus negative 2. We're going to get a new vector. Let's check that. So I have 2 points, which is 7, negative 5, and negative 2. And the second point is negative 2 over 5, 2 over 5, and 1. So find the vector, which is negative 2 over 5 minus 7. Be careful here. And 2 over 5 minus 5, so it will be plus 5. And 1 minus negative 2. V is going to be here, do it on the side, negative 2 over 5 minus 7. That's mean minus 35 over 5. So it's going to be negative 37 over 5. So here's the first component, negative 37 over 5. The second one, which is 2 over 5 plus 5. That's mean it's a 25 over 5. So it's going to be 27 over 5. This is the second one. 27 over 5. And the last one is going to be 3. So here's the vector. Choose this point. Let p equal 7, negative 5, negative 2. And use these 2 components to find the parametric equations. That's the parametric and symmetric. The same thing is going to be x equals x1 plus 80. So x is going to be x1. That means this is x1, 7 plus 8. So it's going to be minus 37 over 5t. Y going to be y1 plus bt. So y is going to be y1, which is negative 5 plus b, which is 27 over 5t. And z is going to be z1 plus ct. So z is going to be z1, it is negative 2, plus c, which is 3, and t. So here is the 3 parametric equations. The symmetric equation is going to be x minus x1, which is 7 over a, which is negative 37 over 5, which is already exists here. X minus 7 over theory. It's going to be, let's check that which one is going to be. And here is going to be y, because this is simplified. Y minus y1, 27. So plus 5 over b is going to be 27 over 5. And c is going to, because they already simplified this vector. I'm going to show you how to simplify. This is the right solution, but if you want to simplify this one, equal z minus z1 over, so z1 is 3 over, z1 is -2, so plus 2 over c, which is 3. What they did, if you look, this is the right parameter equations, but what they did here, you're not going to find one of these, the parameter equations, because what he did here, I have the same denominator here. So what I'm going to do, I'm going to say the vector is going to be, multiply this component by 5, going to be -37. Multiply this one by 5 is going to be 27. Multiply this one by 5 is going to be 15. So the same p is going to be x minus 7 over -37. So that means going to be this one. The y, let's check the y. It's going to be y minus y1 is going to be plus 5 over 27. Not this one, which one? This one. So x, y plus 5 over 27. And the z is going to be z plus 2 over 15. So this one's the, so don't confuse yourself. If you have, this is a good note, if you have fractions with the same denominator, try to cancel these by multiply. So this one is right, but on WebAssign, they used this one as a vector. So let's check if we plug in, because this one is right, but how, because these are options. So you have to multiply by the denominator 5 to do exactly the same vector they used on WebAssign. But on the test, if you write down these steps, I'm going to say this is right. But maybe they're not going to accept on WebAssign. For the next example, you have also 2 points, and these 2 points is easier to use. So go ahead, find the vector first, and then find the symmetric equations. And again, if you got like this vector, try to simplify it just to a numbers. Multiply by the denominator if you have the same one. So you can cancel the denominator and just make it one number. Okay. Example 6. Find a set parametric equations of the line, but the line is passing through the point. So here's the point, and parallel to this vector. So also we have point and we have vector. So to solve this one, they ask you to find the parametric equations. This is going to give you a hint. Passing through this point, that means the point equal -1, 4, and -6. -1, 4, and -6. And parallel to the vector, v equal 6i minus j. That means this vector is ijk. So v is going to be equal 6, -1, and 0. So I have vector, I have point. I can write down the parametric equations. X equal x1, which is -1 plus 6t, and y equal y1, which is 4 minus t, and z is going to be equal z1 which is -6 plus 0 CT. That means this is example 7. Determine whether the plane passes through each point. How are we gonna find this point is belong to this plane, or this point belong to this plane? This one belong to plug in the variables x, y, z. Plug in x, y, z here, you have to get equal 0. Plug in x, y, z here, you have to get 0. Same thing with the c. Plug in -5 and 1 and -7, have to get 0. So let's do just one for question 7. Question 7, to belong, here's the plane x plus 3, y minus 4, z equal -1 equals 0. So I'm gonna plug in this point and check if it's belong to the plane or no. -6, 1 and -1. So this is x, y, z. Let's plug in this one here. So it's going to be -6 plus 3 times y is 1 minus 4 times z is -1 minus 1 is going to be 0. So -6 plus 3 plus 4 minus 1, -6, -1 is going to be -7 plus 7. So it's going to be -7 plus 7, which is equal to 0. That means this point is belong to the plane. Be careful when you're working with the sign. If you got two different sides, that means it's not going to belong to this plane. You can do the same thing for B and C. Find the equations of the plane with the given. The plane passing through the point 5, 2, 1 and the point 5, 1, -5 and perpendicular to the plane this one. We need to find the equations for this part and perpendicular to this one. Let's check how we're going to work on this one. That's me. We have 2 points and we have a vector. We already have the vector for this plane. 8, this is A, B, C. And here is the D. So we have a vector for this one. And we have 2 points. What I'm going to do, this plane is perpendicular to this one. This plane is perpendicular to this one. So I have the normal vector for this one. I need to find a vector for this one. So this one is going to be orthogonal to this one. Let's check that, and we're going to do that in steps. So we have two points. The first point is, let's say this is P equal 5, 2, 1. And the Q equal, the second point is 5, 1, -5. 5, 1, -5. And we have the equations of the plane, which is 8x plus 7y plus 4z plus 7y plus 4z equals 17. That means I have a vector. I can create a vector from this one, which is A, B, C. So this is B is going to be equal 8, 7, and 4. I got a vector from for this plane, and they're telling me this plane is perpendicular to this one. So here's, let's say this is the normal vector. because I'm going to create a vector v from this one. Here's the vector v, which is 5 minus 5 and 2 minus 1. Here's a q, so 5 minus 5, 5 minus 5, and goes from q to p, and 1 minus 2, and negative 5 minus 1. So the vector is going to be 0, negative 1, and negative 6. Here's the normal vector for this plane, and here's a vector belong to this plane. Now, remember, two plane. I have a vector for this plane, and I have vector for this one. I'm gonna find a new vector orthogonal on these two. How I'm gonna find a normal, because this one is perpendicular to this one. To find the normal vector for this plane, the cross product is going to be orthogonal on this one, which is the normal vector for this plane. So if I say V cross product with N is going to be, this is I, J, K. Always the J is negative. So I'm going to write down the vector V, which is 0, negative 1, and negative 6, and the normal vector 8, 7, and 4. Again, they're telling you this plane is perpendicular on this one. So if the dot product between these two planes or between these two vectors is going to be orthogonal 100% of, sorry, the cross product 100% is going to be orthogonal on this plane, on this one. It's orthogonal on this plane. That means this is the normal vector for this plane, and I can choose any points to create the parametric equations. So this one is going to be equal 0 for the I. That means it's going to cancel the whole I. So it's going to be for the I, negative 4 minus, is going to be plus 42. This is for the I. For the J, minus, for the J is going to be 0 times 4 is going to be 0, plus 4, 8. This is the J. Plus, for the K, is going to be 0 plus 8 for the K. That means is going to be 42 minus 4 is going to be 38. I minus 48 J plus 8K. That means the new vector, this one is going to be the normal vector for this. So what I'm going to do, this one is going to be A equal 38, which is the new vector. B is going to be negative 4, 38, and 48, negative 48, and C is going to be 8. So I have choose any point. We can choose the first one, which is 5, 2, and 1. So I'm going to choose the point B, which is 5, 2, 1. So the general, they ask you to find the equations. That means the general or the standard form. So A, x minus x1 plus B, y minus y1 plus C, z minus z1 equal 0. A is going to be 38, x minus x1, which is 5, plus B, which is negative 48. So I'm going to put negative sign here. Y minus y1, which is 2, plus C, which is 8, C minus Z1. If you write down like this, it's going to be right, simplified to the standard form of the general form. So 38x minus 38 times 38 times 5 is going to be 190. That's 190 plus or minus 48 y plus 48 times 2 is going to be plus 96 plus 8z minus 8 is going to be 0. Now we're just going to combine the like terms, like 190 and 96 and 8 is going to be negative 1 or 2. That means 38x minus 48y plus 8z minus 120, no, 102 is going to be 0. That means 38x minus 48y plus 8z is going to be equal to 1 over 2. So this is the equations of the plane. That's it for this. Check, determine whether these two planes are orthogonal, parallel, or neither. So what we're going to do, the normal vector from the first plane is just write down ABC, which is 8, negative 5, and 1. 8, negative 5, and 1. And the normal vector from the second plane is going to be 1, 3, and 7. 1, 3, and 7. They're telling you, find the dot product between N1 and N2. It's going to be 8 times 1 plus negative 5 times 3 plus 1 times 7. So it's going to be 8 minus 15 plus 7, and the result is going to be 0. So of the dot product between N1 and N2 equals 0, that means these two planes are orthogonal.
Okay.
That's it.
Okay.
Now we're gonna go to the sketching. That's also important. You're gonna do exactly the same steps I showed you, okay? And they're telling you, this is example 10. We can do that. So let's find for example 10, question 10, because this is important. We're gonna do exactly the same steps for scratch any lab. We're gonna do, first of all, let's write down the equation, which is 4x plus 2y plus 7z plus 2y plus 7 z equal 56. I'm not going to look to the graphs and make guessing. No, find the points so you can practice on. The first trace is xy trace. That means z is going to be equal 0. So here's the equations: 4x plus 2y equal 5, 6. Okay, now we're gonna graph this one. Find 2 points here. Let x equals 0. That means 2y is going to be equal 56. That means how much is going to be y? 56, you're gonna divide it by 2. It's going to be 28. That means y is going to be 28. So the first point, x is 0, y is 28, and z is going to be 0. Let y equals 0. I'm gonna plug in y equals 0 here. So it's gonna be 4x equal 56. That means now 56, you're gonna divide by 4. How much is the result?
56 divided by 4.
It's gonna be 14.
It's like 16? Oh.
No, 14, because you're gonna divide this one by 2, is going to be 14. That
Yeah.
means x is going to be equal 14. So the second point, x is 14, y 0. You see, here is the first point, and here is the second. I'm done from xy trace. The second trace is, let's do yz trace. That means x is going to be equal 0. So go back here and plug in 0. That means 2y plus 7z is going to be 56. Let y equals 0. That means 7z equal 5, 6. Then z is going to be equal 8. That means the point is going to be x is 0, y is 0, and z is going to be 8. Let z equal 0. That means 2y is going to be 56. Then y is going to be equal 56 divided by 2 is going to be 28. So the point is going to be 0, 28, and 0. Is that the same point here? See this one?
Yes. Yeah.
So we already we know the point. This one,
Yep.
this one, and this one. Let's
I
check
get it
that.
now.
Yeah. Let's check now the third trace, which trace we have? xy, yz, xz. Xz, so yeah, so xz, that means y equals 0. So y equals 0, I'm gonna plug in y here. So 4x plus 7z is going to be 56. Let x equal 0, that means 7z equal 56. That means z is going to be 8. So it's going to be 0, 0, 8, which is the same point here. Let z equals 0. That means 4x is going to be equal 56. That means x is going to be equal 14. So it's going to be 14, 0. You see? If you got different points, that means you have something wrong. You need to check. So let's write down the point. The x-intercept, which is this point, okay? 14 with the x coordinate, 0, 0. The y-intercept, which one is the y-intercept? The one with the y, which is the 28. That means 0, 28, 0. And the z is going to be 0, 0, 8. There's the intercept. Now let's check with the graph. Which one is going to be the right one? 14, 0, 0. Check the x is 14. Let's check this one. 2, 4, 6. No, it goes. I don't think so. It's going to be. It goes by 2. 2, 4, 6, 8, 10. This is 10. This is 12. Okay. So this is wrong. Let's check this one. 2, 4, 6, 8, 10, 12, 14. So this side is right. X is right. Let's check the y. The y is going to be 28. Here's the 20. This is the y coordinate. Here's the 20. 2, 4, 6, 8. So the y coordinate is right, 28. Let's check the z. The z is supposed to be 0, 0, 8. You see, this is 10. So here's 5, 6, 7. No, this is the 5, 6, 7, 8. So this is 8. That means this is the right choice. That's it for this example. Let's go to question 11. Find the distance between a point and a plane. So the point is 154. 154. And the plane is x minus y. Oh, this is 12. 11.
Yeah.
The point is 0. I think the same thing. So on 11. And the plane is 2x plus 6y. 2x plus 6y plus z equal to 12. Plus z equal to 12. Here's a plane and here's a point. I need to find the distance. The first thing, the normal vector for this one, for the plane, is going to be just the A, B, C. This is A, this is B, and here's C. So it's going to be 2, 6, and 1. This is the normal vector. I have the point. Now I need a new point, Q. Remember the new point says what?
Yeah.
It says negative.
Negative d divided by,
Yeah, but be careful, you have to move the d to this side.
yeah. So
So
it'd be
it
negative.
looks like just d, which is 12 by 2, and here is zeros,
Just 6.
which is, let's write down the rule. It's going to be 7. Because here is negative 12. That means it's going to be 12 negative d over 2 over 8. So Q
Wait, over.
is going to be 12 over 8 is 2. Yes, it's going to, oh yeah, you're right. You said 6?
Yeah.
So Q is going to be 6, 0, 0. So now I have the Q, and here's the point P. That's what I'm going to use to the new vector PQ is going to be 6 minus 0. 0 minus 0 and 0 minus 0. I have this vector and I have the normal vector. Can I find the projection? Yes. Distance is going to be the projection of PQ over the normal vector, which is equal the length of the dot product, not the length, the absolute value of the dot product over the length of the normal vector.
Wait, what
The
does
length of the
projection
projection.
mean again?
The projection, you're going to project this line. You see, let's do a simple graph. So consider this is the plane and this is a point. Let's go back to the graph. You're going to project the line. That's mean you're going to yes. Remember this graph?
Yeah.
You see, here is the normal vector, and here is the PQ vector. You're going to project, that means this is belong to the line. You're going to project this one on N. Project this one on N. This is the projection. That means you're going to take this line and put it on N, okay?
Oh, okay.
Yes, just look like this. So it's going to be projection. Project this line on N, okay?
Interesting. Okay.
So the normal vector, the length of normal vector is going to be the square root of 2 squared
4.
plus 6 squared plus 1
Mhm.
squared. So
Plus
the normal vector is going to be square root of 4 plus
40.
6
41.
plus 1 square root of 41. What else we need to find? We need to find the product. The product between PQ and N is going to be, here is PQ and here is N. It's going to be 2 times 6 plus 6 times 0 and 1 times 0.
So just 12.
Plus 1 times 0. So it's going to be 12. That means the distance is going to be the length of this one, not the length, the absolute value of 12 over the length of N is going to be square root of 41, which is equal to 12 over square root of 4. That's it.
Okay.
The same thing is going to be exactly with example 12, but the difference, the point here is 0, 0, 0. The point here is not. It's 1, 5, and 12, 4. For example 13, I need you to think about that. You have 2 planes. The first part is to find parallel. How? By finding the dot product between N1 and N2. And check for these 2 planes, they're missing the Y coordinate. For find the distance, choose one plane and choose another plane, choose a point for the other plane. And do exactly the same steps for the previous example. So you're going to choose this plane and choose a point for the other plane because it's going to be outside the first plane. That means you're going to get a point here and you're going to get the plane and find the distance. And it doesn't matter if you choose a point for the first plane and use the second one as a plane, it's going to be the same distance. Okay?
Yeah, I get it.
So fix one plane and get a point from the first plane and find exactly, it's going to be exactly the first, example 12. For 14, we need to find the distance between a point and a line. So let's work on example 14. Sorry, we're done. Need to solve this one. 14. So the point is P equal 4, -1, 6. 4, -1, and 6. And the plane is x equal 2t, and a line, sorry, not a plane, t minus 3, and z equal 2t plus 2. 2t, yes. So here's the parametric equations for the line. So now I need a point here. I have point here. And I need a point outside. So now this point is outside this plane. How are we going to check that? To find a point belong to this one, let Q equal. I'm going to let T equal 0. If T equals 0, X is going to be 0, Y is going to be -3, and Z is going to be 2. So here is the point Q. The normal vector N is going to be P belong to this plane. Let's check that. If you plug in X here, 4 equal 2t. T is going to be equal 2. Plug in -1 here is going to be
-2.
3. Plug
Oh,
in
yeah,
this one,
yeah.
the -2. Yes, you're right. It's going to be 2. Plug in 6 here. 6 equal. Plug in this one 4 divided by 2 is going to be. So this one not on the line. This one belongs to the line. Okay.
Mhm.
Now the normal vector is. How are we going to find the normal vector? A, B, C.
Yeah, A,
How
B,
is
C.
the H? The A is 2. B is 1. C is 2. So I have normal vector and I have point. Now PQ is going to be equal. Here's the P and here's the Q. So it's going to be 0 minus 2 is going to be -2. -3 minus -1. -3 minus -1 is going to be -3 plus 1 is going to be also -2. And 2 minus 6.
That first point on the PQ, like 0, wouldn't it be 0 minus 4 and therefore -4?
Oh, you're right. 0 minus 4. Yes. I put it with this one.
Mhm.
Okay, so -4, -2 because -3 plus 1 and 2 minus 6. Okay, good. Now now how to find the distance? Before that, I'm gonna find the length of the normal vector, which is going to be square root of 2 squared plus 1 squared plus 2 squared.
Plus 4.
So it's going to be 4 plus 1 plus 4. And it's going to be square root of 9. And this one is going to be equal
to 3.
3. Then the distance is going to be the length of PQ cross product with N. That's the difference because it's a line. Over
Divided by
length.
3.
Yes, we only have this one. Now we need to find the cross product. Let's find the cross product PQ. Cross product with N is going to be I, J, and K. This is always negative. PQ is going to be -4, -2, and -4. And N is going to be 2, 1, 2. Then this one is going to be, for the I, is going to be -4 plus 4. I. Minus, for the J, it's going to be -8 plus 8.
Mhm.
Plus, for the K, is going to be -4 plus 4.
Oh, shoot. Doesn't that mean they're perpendicular?
Because the cross product is going to be 0. That means they are perpendicular. But how much is going to be the distance?
It's going to be 0.
It's going to be 0.
Okay.
That's mean this one is the K. So it's going to be 0. So the distance is going to be, I'm gonna check that. If not, that means we have something wrong. Because this one is going to be 0 over 3, which is
3.
equal to 0. Let's check that. What they tell you is a question. Let's type 0.
Do 15 and 16 on my own.
Yeah, 15 and 16 is going to be easier. Just you have to true or false. Okay?
Yeah.
That's
Yeah,
it.
and I'll look at the video.
Yeah.
All right.